Rutherford's model of an atom. Ernest Rutherford was interested in knowing how the electrons are arranged within an atom. He designed an experiment called alpha scattering experiment or gold foil experiment. In this experiment, fast moving alpha particles were made to fall on a thin gold foil. He selected a gold foil because he wanted a thin layer as possible. This gold foil was about 1000 atoms thick. What are alpha particles? Alpha particles, they are doubly charged helium ions. Since they have a mass of 4 units, the fast moving alpha particles have a considerable amount of energy. It was expected that the alpha particles would be deflected by the subatomic particles present in the gold atoms. Since the alpha particles were much heavier than the protons, he did not expect to see large deflections. The diagram shown here is the scattering experiment done by the Ernest Rutherford. As you can see that alpha particles were made to fall on these gold atoms which are present in a gold foil. Now, many of the alpha particles, they went straight without any deflection. Some of these particles, they deflected back through small angles, and some of them bounced back through 180 degree. So, he made the following observations. Most of the fast moving alpha particles passed straight through the gold foil without any deflection. Some of them were deflected by the foil by small angles. Surprisingly, 1 out of every 12,000 particles appeared to rebound. Conclusions. Rutherford made the following conclusions. Most of the space inside the atom is empty because most of the alpha particles passed through the gold foil without getting deflected. Very few particles, they were deflected from their path, which indicates that the positive charge of the atom occupies very little space. A very small fraction of alpha particles were deflected by 180 degree, indicating that all the positive charge and mass of the gold atom were concentrated in a very small volume within the atom. From this data, he calculated that the radius of the nucleus is about 10 raised to power 5 times lesser than that of the radius of atom. On the basis of his experiment, Rutherford put forward the nuclear model of an atom. And the following are the features of his nuclear model. There is a positively charged center in an atom, which is called the nucleus. Nearly all the mass of an atom resides in the nucleus. The electrons revolve around the nucleus in a well-defined orbits. And the size of the nucleus is very small as compared to the size of the atom. As already mentioned, that the radius of nucleus is about 10 raised to power 5 times lesser than that of the radius of atom. Drawbacks of Rutherford's model of the atom. Although Rutherford gave a proper explanation about the presence of nucleus inside the atoms, but there were certain drawbacks also. According to Rutherford, the electrons revolve around the nucleus in circular paths. The orbital revolution of the electron is not expected to be stable. Any particle in a circular orbit, it would undergo acceleration. During acceleration, the charged particles, they would radiate energy. Thus, the revolving electron would lose energy and finally it will fall into the nucleus. If this were so, the atom should be highly unstable and hence matter would not exist in the form that we know. But we know that atoms are quite stable, they are not unstable. So, this was the major drawback of Rutherford's model of the